All right. Hi, everybody. All right, you hear me well. So, some of you I have met before. Some faces are quite new, and if you don't know who we really are to begin with, we actually have a background from big corporates where we have been developing a lot of smart devices, and what we struggle with quite a lot is the fact that we didn't have hands-on accessible tools to actually realize and understand how should we design for the long battery life. So the background that we have actually is we are solving the problem that we had ourselves. And it relates very much to the actual headline on the title of the talk. Why does our datasheet still live in kind of ideal space and world? Because most of you understand that, right? As soon as you start designing a device, you realize that the pursuit for perfection is actually much more important than achieving the perfection. What I mean by that is that we figure out really quickly that the art of the compromise. And that's something that is quite normal considering the fact that everything that we are designing is something that will be affected by so many different types of variables. And if you consider different types of integrated devices, you will know very much that most of those operate in a ways that vary much from the what is usually advertised, right? And as an engineer, you kind of accept that and you design accordingly. But you realize that during the development phase, you need to consider that those kind of variations are going to affect the work that you're doing and the performance that you're going to be achieving with your product. Now, considering the fact that we have so many different variables and that it's never really ideal, what do you really do? Why would we then accept the fact that the data sheets are just talking about typical values, right? That's kind of a thing that you can get me a little bit bothered. However, I realize really that it's not really a problem with the data sheet. It's actually a problem with us. It's a problem with the mindset, because we are the ones that use this, and marketing a very complex thing, such as battery, for example. I mean, you can't do anything else but do a data sheet with the typical values because there is such a complexity around it. But it's us that are taking the shortcuts. What we usually do is we go for the estimation. We go for the quick fix where we take some numbers out of the data sheet. We combine that with certain single snapshot of how we think our application will work, and we go on with our lives and think, hopefully that will do. But considering the fact that we are now a growing community of developers, especially the IoT, and we kind of need to set the right example of how to do this, we need to consider if this is the right mindset to go with, because from the company's perspective, of people who are going to be buying this is going to be an issue. And I talked about this before many, many times about maintenance costs, reliability, the fact that the user experience is going to be worse, but also the fact that we are teaching now the new generations of developers that it's fine. Just look this, kind of hack it and go with it. Instead, we should be doing something else. And at Qoitech, we really are passionate about thinking about beyond the data sheet. Yes, you will use the data sheet. Yes, it's helpful, but it's not how you should be doing when you are going through a development phase. You should be really thinking in how do you incorporate measurement and continuous ones throughout the whole development phase. And that can be a little bit bothersome because you, of course, think, yeah, that takes time, that takes money, but what you earn out of it is so much bigger than of course, what you have put in, so you have to consider the later effects. Now, usually we say, okay, we want to set the right example. And to set the right example, we need to kind of see what is the right example. So the right example is very different for different people. What we believe it's the right example is actually two different types of best practices. And this is one of them. And I think if you really, really want to go and dig into details about all these two, and they're more and they're more complex than that, you should definitely come to our workshop today and tomorrow. And if you haven't got the spot, please find us at the booth. We're just here outside, and we can kind of dig into it. But I'm going to be simplifying it, saying, OK, there are two best case or best practices. And one is know your application, the first one. So, and by that I mean know your application throughout the whole development process, meaning don't wait until the launch. Because there are too many people that they do estimations in the beginning of a project, and then somewhere along the line, you forget about the battery life, and just prior to the launch, you realize, crap, this is crap. And we actually recently met a quite large company that was in a similar situation there. They were just about to launch, actually go to mass production with their sensors, and they picked coin cell battery for their solution. Now, this wasn't a LoRaWAN technology, so for the form factor and for the technology that they picked, this was pretty much a good choice. But they forgot about this kind of follow-up, what is actually happening during the development. So they kind of had they kind of knew what is going to happen or what they wanted to happen, but during the development phase, the power profile changed dramatically. So at the end, they actually had a power profile with really, really high peak currents. And Caroline, just before, was talking about how different batteries react in really high peak currents. And in this case, it actually happened in that they got into this high internal resistance. The voltage dropped way before they expected it to drop. So it killed the device way before any of the capacity they wanted to actually get out. So I think it was maybe 30% of the capacity they got. And this was just weeks before they are actually going to put this into works. And you think, OK, so let's go back and fix it. In their case, it was actually a hardware problem. So fixing a hardware problem that late in the development process, it's very costly. And it's costly for a large company, and if you're a startup, it might just be you just have to close down because you can't iterate that process again. So you really need to consider the fact that there are changes that are going to be happening in your hardware. You're going to be changing. You're going to be having second source components. You're going to have software on top of it that is going to be changing. You need to keep track on what is happening, and you need to make sure that it's actually that once you are launching on the knowing that the battery life, not that just you're going to deliver on what you promised, but you're actually going to have something working, because in some cases it might not happen. So what do? Best practice. Well, you need to profile your IoT device. This is the #1 thing. You need to make sure that you know what kind of a current profile you have to start with, and what are the activities that are happening, what is actually happening, what is draining the power. And when you kind of profile that, when you understand this, you will then much easier go back and say, well, now I would like to have this goal profile. And together with your designers, with your battery suppliers, with your component suppliers, and with your software engineers, then you can set reasonable goals and say, OK, guys, what are you going to be doing to make sure that the profile that we want to have is going to be there along the whole development, or especially at the end of the project. So profiling your device, the key thing, continuously, definitely. Test, change, test, and compare. I mean, regression testing, you might think it's boring. You might think it's a lot of work. But the fact is, this is where you can actually see. When you compare what your initial curve with your second curve, it can be just a line of code that you have changed. And you see the difference on your profile. You see what is happening. Then you will realize how much more it actually gives you, and what kind of changes you can do to go either back to what you wanted to have in your profile, or to even improve it further or on the other side. So testing, changing, regression testing, that's extremely important. So second best practice. So one was know your device. The other one is know your battery. And here it's black magic. Really, I think it's black magic enough with the knowing your device, but it's definitely black magic when it comes to the battery, because usually you are not supposed to be the expert on batteries. You are supposed to just buy something and use something. But it's not that easy. So when it comes to the batteries, you really need to understand their behavior, and you need to understand how this integrates with the application that you have. So there are two ways to do that. One is obviously, or actually both of them, you should be doing in parallel. One is talking to a battery supplier. They know, they are the experts, so they should be telling you, and they should be showing you how it works. So not just the datasheet conversation, but literally for your application, they should be telling you this is how it will work. The other thing is, of course, to test your battery yourself. And I'm using here an example of our customer, SenseFarm. There are hopefully some people here from SenseFarm as well. You can catch up with them. They are an IoT sensors and services company within the agricultural space. And what they have been doing lately was actually they were in a project, they were picking the batteries, and they were trying to figure out, okay, so is this the right battery for us? And they wanted to put it to test. They used our OTI, our tool OTI, with our latest edition, which is the OTI battery toolbox, which gives you the opportunity to actually go into depth of how these batteries work for your application. And they tested it and realized really quickly that the spec was saying that you could do about 27,000 transmissions. At already 10,000 transmissions, they got into trouble. And this was something, of course, that is a big no-no. If they haven't seen that type of problem, they could have deployed something that actually was just using half of the capacity, which is obviously not a good idea when you are putting devices at the edge of the network and you are trying to do this on a single primary cell. Not a good idea. So they, of course, changed the battery supplier, and they could go to the battery supplier and say, here's what we actually see, and this is not acceptable. So let's see what you can do. Can you do better? And they could find somebody better. You can always find somebody better. So how do you profile the battery? Well, magic again, and that magic can be explained by the experts in our booth. What I can say here very easily is what you do is you're actually discharging, you're connecting your battery, you're discharging for the specifications that you have for your own application, which means you're picking how the currents look like, how often this is going to happen, the times, the levels of the currents, and you discharge it to the voltage that you want to discharge, which means you're actually making sure that it's behaving according to what your application, how your application is behaving. So in this case, you're actually going to get discharge curves for the batteries according to what you actually would assume will happen in your application. And if you know that your application is going to change, you can then profile it when this application changes. So you always have the updated curve, so you know whether this specific battery that you might have chosen is working all the way through your development process. Once you have done that, you emulate the battery, meaning that you use that discharge profile and you actually play it on top of your application. So you plug in your device and you actually play it on instead of using a power box, which we all use. I mean, our go-to thing is power box and a datasheet, right? And this is what we want to change. We want to say, yeah, go and check your datasheet. It's good for comparison, quick check. But if you really want to have something on a developer table, it should be something that gives you a battery that actually profiles on top of your application and not just a normal power box. So this toolbox actually elevates our power box into something much more specific, and you play out this specific, and you can actually use that and see whether this works for you or not. And I want to give you an example of we have done many studies with this, but this is one of them that is actually going to be shown in the workshop. So if you're interested in what the battery A and Bs are, you should be talking to the people outside in the booth. They are, this is a coin cell example, and doesn't really matter, I would say, because it's very different. All of these different batteries, they are very different, they're very complex, but they are also very different from each other. So if you compare, in this case, two different batteries, coin cell, and you would assume, you go from the datasheet point of view, say, okay, so capacity is about 600 milliamp hours, that's it, this is where I'm going, and I don't do my average current. Then I realized real quickly that, okay, I can probably fulfill the battery life that is 9.8, 10 years, this is what I promised to my customers, great, everything is fine. But then you take it a step further and say, okay, let's profile the battery. Let's now put a discharge such that it's actually according to, my currents and my timings, and see what is actually going to happen. And when doing that, you end up seeing that with an open circuit voltage, you actually measure capacity that is much lower. So you started with, for the battery A, it's 610, and now it's 224. Whereas the other batteries, yeah, they were actually honest with 500 and 444. Maybe, yeah, that looks okay. And then you take the third step and you actually emulate the battery. Emulating, in this case, you are replaying that profile, and now you are iterating that until your device dies. So you actually is seeing what kind of capacity you can extract for your specific device, and you end up with even lower. You end up, in first case, less than 100, whereas the battery B is still keeping kind of strong, about 400. So I would say then the choices of the battery is probably much more clear for you, but you have to understand that even if the choice is clear, the data sheet part is not realistic. You cannot promise your customer a 10-year battery life. And definitely you have to consider this during the whole development process if you are to make sure that this is going to be relevant in the beginning, in the middle of the project, and definitely at the launch. So to summarize, we see that we need to make a shift in the mindset when it comes to battery life. For obvious reasons, that we need to do really high-quality products, and we need to teach new generations of developers that this is the way how to do it. And considering the fact that they don't necessarily have very elaborate labs or hardcore engineers to mentor them, they have us, the community, and we can set that example by saying, okay, there are certain best practices around this. And those that we propose are the fact that you measure continuously. You make sure you profile your IoT device, you understand it, and you understand it throughout the whole development process. And you profile and emulate battery for your application, so it is very integrated into your development work. You understand what is happening. With that, I thank you for listening, and I have no idea what time is, so I don't know if we do have any questions.
We have time. Thank you so much, Vanja, first of all.
Yes.
Yeah.
Thank you.
Yeah, so know your device, know your batteries, but also understanding your variables. The last thing I can understand as a developer, you cannot do that alone. You really need to find a lot of collaboration to understand those variables. Is that?
Well, the thing is, when it comes to your own device, it's you and your team.
Yeah, of course.
It's that simple. And if you don't know that, it's really hard to collaborate, for example, with a battery supplier, because they can give you what they think you're going to be using. But if you're really certain you understand your application, then you can request things from the battery supplier, and they will be much more honest to you. Well, it's not about honesty, more like concrete about how they can help you.
Great. Yeah.
So the tools that we provide, it's for everyday use, but also it's a communication tool with others to say, okay, this is what I have. What can you how can you
advise best?
How can you use that?
Yeah, very good. Any questions to Vanja? Yeah.
Well, hello.
Hi.
Can you recommend any programs to make these measurements or simulation according to the battery?
Well, it depends on what you want to do. Again, we do have our OT tool, and I highly recommend to go and check it out and see how it works for us. When it comes to the pure simulation part, I mean, there are companies that are doing that as well. One is WiseBet. It's a quite good company that we also collaborate with, and they're more focusing on the actual simulation of it. But if I would say do both, and I would definitely say, like, as an engineer and a hands-on engineer, I don't go anywhere without actually checking something and measuring it. So the booth outside, how many times can I say it? You know where it is now?
And the workshop this afternoon and tomorrow as well,
Yes,
huh?
correct.
Yeah, okay, thank you so much, Vanja.
Thank you.